It's my pleasure to meet you. And today we would like to present to you our project City Ride, which we developed past 5 weeks. And to start with, we are thrilled to introduce our team. By the way, I'm Nastya. It's a group of dedicated individuals who have embarked on an incredible journey together. Throughout our shared experience, we have not only grown both personally and professionally, but also had a privilege to being guided by exceptional mentor whose presence has made our journey all the more fulfilling. As we worked collaboratively towards our goals, we faced challenges that tested our mettle. Now I'm giving the floor to Oleh.
Hi, so I'll be telling you a bit more about the project itself. So as Yevhenii has mentioned before, it's a transportation project, and it aims to provide a platform for both clients and drivers to communicate and arrange the rides. So basically we have two gateway APIs, one for the drivers and for the clients. And they both have console applications for interactions, and basically the flow is that the client can get an estimate of the price, and then he can make a decision on whether to request it, and the request comes to the driver and he also can make that decision, and so on. And on to the next slide, I think.
I'd like to highlight a few key points about our system. So for non-functional requirements, our system should be able to handle large number of simultaneous ride requests and handle large number of drivers. For security, rider and driver should both be authenticated before getting access to the system, and the system should validate all inputs from users. Our sister is built on ASP.NET Core, Entity Framework Core, and Postgres database, utilizing microservices architecture pattern for scalability and flexibility. Next slide, please. So now let's take a look on our Scrum board. So we had daily stand-ups, which kept us informed and aligned. And we also had a sprint review, which gathered the valuable feedback. We used a powerful project management tool called Trello, which provided us with a visual and organized platform to manage our tasks, track projects, progress, and collaborate effectively.
Right, so which technologies have we used? So it was written in ASP.NET Core and using Entity Framework Core. And in terms of databases, we have used Postgres because it's very lightweight, so it's easy to publish, and also it provides a great implementation for working with geographical coordinates, which we needed, obviously, for this application. And other technologies include SQLite for other database purposes, and Redis for cache. Also, we used Kafka for communicating with requests between the microservices and Docker to host all of this. And about other technologies, Alina will tell you.
Yes, thank you. We also implemented the repository pattern for our services. It helped us to separate the data access logic from the business logic, and it provided us with a better and structured way to interact with the database. Also, the next technology we used was JWT authentication, which provided us with more secure access for both clients and drivers. We'll talk about that later. And the next one is Trello, which Mariia talked about previously. We used that as a project management tool, and GitHub, we used that as a version control platform. We created separate repositories for every microservice. within our project, and also we used Fluent Validation Library for input validation and data validation in our APIs. And when, for example, we created a driver or updated driver, we defined some important rules for our fields, for example, email or phone number. And also we use dependency injection as a design pattern to help us manage our dependencies between different components in our system. Yes. And about the services, so during the development of our project, we, as Yevhenii mentioned, we made a decision to adopt a microservice architecture, and because it was very beneficial for our project, and it helped us to improve performance and scalability. So yeah, it had its benefits. And throughout the process, we mostly focused on following the principles of microservice architecture. So every microservice that we created was designed to be independent and with its own data storage and business logic, so that every modifications to our microservices or any kind of updates wouldn't impact the functionality of other microservices, which is nice. And our microservices that we defined during our brainstorming sessions were write service, client service, billing service, and driver service. And we'll talk about them more later into our presentation. We also created 2 console applications for the driver and the client, and 2 nugget packages. For one of them was domain, which was basically a project that contained all the entities used by all our services, and also events that was the package that contained all of the events that were used in our project, and also the deployment Docker Compose file for the project deployment. Thank you.
As you already know, we made a project based on microservice architecture. We have 2 client apps, one for client and one for driver. Client connected to this client service via Signal R. And as you can see, each service has their own database to store data. But write service has also Redis for caching drivers. However, client service makes a request to billing service for calculating write prices, and messaging between client service and write service takes place through Kafka, what provides scalability and reliability of the system. Write service makes a request to the driver service for searching closest drivers. Also, driver app make a request for driver service for authentication of the authorization. And driver connected to the write service via Signal to get requests from the clients.
Okay, so I hope you see the next slide. And I would like to concisely describe the folder structure, which had each microservice which was already introduced. For example, we had the main folder source, and then which contains API, application, domain, and infrastructure. API contains the entry point of applications such as controllers or routes, and that handle HTTP requests and responses. Application contain the application layer, which serves as an intermediary between the API layer and the domain layer. It encapsulates the business logic and coordinates the interactions between the API and the domain layer. Domain layer represents the domain layer, which contains the core entities, value objects, and business rules of application. And last but not the least, it's infrastructure. It encompasses the infrastructure layer, which handles external dependencies and technical details. It often includes implementations of repository interfaces and data access objects and database configurations, for example. And at the start of our project development, I was responsible for creating a microservice that resembled a write service. So as was already mentioned, write service is a microservice that handles write-related operations, like it receives write requests from client and communicates with the driver service to identify the 5 nearest available drivers. Once a driver are selected, write service is responsible for notifying them about the write request using singular, and write service is involved in creating the write itself and updating the write status as it progresses.
At the beginning of the project, driver service was my service that I had to create. So basically, it's a microservice that is responsible for managing the drivers, and it provides the functionality to perform CRUD operations and any kind of operations that are related to driver. It also incorporates GWT authentication for secure access, and it also handles the status of the driver, which can be connected or disconnected and can be changed when the driver is logged in and his location is updated. And also it is responsible for searching the 5 nearest drivers for the ride. And yeah, I guess that's it.
So at the beginning, I was working on client service, which is a microservice that handles ride-related functionalities for clients. It is responsible for receiving ride requests from clients and providing them with the price of the ride. To do that, it communicates with the billing service to process the price calculation and enables the client to accept or decline the ride offer. Additionally, client service utilizes SignalR to send real-time ride status updates to the client, and the microservice incorporates CRUD operations for managing client data and implements GWT token authentication for secure access.
Right, so next service is billing service. So this is the service that is responsible for telling the client the estimate of the price of his ride. And basically it does 2 things. First one is it provides an API method to calculate the price, and also it exposes a CRUD API to work with entities that store different parameters for each car class. So for example, we may have like a common car or a green car or a car that allows pets, and for each of those we have these parameters, a coefficient factor, the cost per kilometers, and some extra fees. And whenever the client sends a request, he gets a response of how much that would cost him, and then he can make a further decision on whether they want to book this ride.
Unfortunately, we won't be able to show project in action because Docker is not working for some reason.
Okay, so we have such a problem, and we will move to the next slide, where we would like to give a few commentaries about the practice which we had. I'll start. I had a learning experience in which I enjoyed everything. Working with both my teammates and our mentor was a great pleasure. If I had any problems or any kind of question, he always answered promptly and understandably.
Yeah.
Okay.
I enjoyed this practice so much. It was really interesting and useful, and I enjoyed working with my team. I surely gained a lot of knowledge and learned about different technologies, and that's thanks to our mentor, who helped us a lot and shared his knowledge with us.
I would like to support everything that the girls said, but also I would like to emphasize on the lectures that we had. Those were really helpful because a lot of the technologies were really new to me. So it was a great way to dive into the technology, and also the mentor was really helpful, and the idea of working in a team together. I loved it. Thanks.
Also, I can add from myself that Yevhen was always very prepared with his materials that he showed us on many different approaches and technologies that we have used. And also, he was always very quick and happy to help us. And I also really enjoyed his code reviews because it has taught me a lot, and I could always see the reasoning behind every decision that our team made.
I joined the words of teammates, and I would thanks to our mentor for his job.
Hi, this is our project at work. As evident, we have opened one console for the client and 3 consoles for the drivers. Each console is set up for drivers and clients who are ready to log into their respective accounts. We have pre-configured these accounts. Once logged into the client console, it prompts us to enter the source and destination points along with the desired card class to create a ride request. The client then receives a price estimate for the taxi ride and can proceed to either initiate the ride request or decline it. Upon initiating the request, the system sends a notification to the 5 nearest drivers who have the appropriate car class. This notification contains detailed ride information and enabling the drivers to decide whether to accept the ride or not. Once a driver accepts a ride, all other pending requests are automatically cancelled. In case a driver doesn't make a decision within the specified time limits, their ride request is automatically cancelled too. Drivers also have option to temporarily halt ride request notifications if they haven't in any active ride during that time. The driver can begin and conclude the trip, and the client console receives timely notifications regarding these status changes. Thank you for your attention and have a nice day.